Okay, so you all are here. Wait, I can hear you. Yes. Okay, so let's start the class. What we have to discuss. How many students have joined? Only three. Okay. Well, what we have to discuss is wait a little, organic chemistry. So let's just start from the reaction. What we have done yesterday. We did something like substitution reaction, elimination reaction, uh, and the alkane and the alkene, and something about polymerization. Well, now move. First of all, I guess everyone knows what is homologous series, but let me remind you again, homologous series. Homologous series, basically, this is a series of organic compound which is having same functional group. For example, there are two carbon chain and there is OH attached, or for example, if there is three carbon chain and there is OH attached, or for example, if there is five carbon chain and there is OH attached. So you can see these are the organic compounds and these are not hydrocarbon, because um, hydrocarbon means one should be having only hydrogen and carbon, but it has oxygen also. So it is not hydrocarbon chain. This is the chain of organic compound. Okay, so you can see these chains have same functional group. So they belong to the same homologous series. But for example, if I attach one chlorine here, so it belongs to some different homologous series now. Okay. Other than this, I guess you all know about saturated or unsaturated. Saturation means, for example, if this is a carbon, all the bonds of carbon are busy with other elements. So this is called saturated one. Unsaturated means carbon-carbon double bond. If you have a hydrocarbon chain, or if you have a chain of organic compound, and if that chain has carbon-carbon double bond, it means that is called unsaturated hydrocarbon. Um, Other than this, hemolytic and heterolytic fission. Yes, that's what we have to discuss today. What is fission? Fusion means, for example, this is one thing and that is another thing. So fusion means you have to fuse them together and you will get one larger thing. That is fusion, which is being done inside the sun. Fission means this is something larger and you will break it into two pieces. That is called fission. So fission means the breakdown. Like we did cracking in the previous class. The cracking means the breakdown of compound. Decomposition means the same in chemistry. So fission means the breakdown. So what we have to break down? We have to break down a compound, a chemical. Okay. Um, let's take some example. Let's take the easiest example, HCl. This is an inorganic compound, but let me tell you, if you're discussing reactions from, for example, if you're you to absorb the thing. Okay, so this is HCl. Everyone knows that this is organic. This is a part of organic chemistry. HCl is a part of organic chemistry, but we are also using HCl here as a catalyst somewhere, or we are using HCl in substitution reaction or addition reaction, you can say. Okay, for example, this is HCl. If I ask you to break it, so definitely it will be broken down into hydrogen and chlorine. But how it can be broken down? Uh, how HCl is made? This is hydrogen and this is chlorine. Hydrogen has only one electron, which is being shared with the chlorine. Chlorine has 7 electron, in which from which only one is being shared with the hydrogen. This is HCl. Okay, if I ask you to break it, so how can you break it? You all know about the electron negativity. Electron negativity is the tendency of any atom to attract the shared pair of the electron. So here, chlorine is more electronegative. Everyone knows chlorine. I mean, the halogens like fluorine and the chlorine are more electronegative, like oxygen and the nitrogen are more electronegative. So what is happening here? This shared pair of electron is being holded by the chlorine. Okay. So if I ask you to break it, so you know very well, chlorine is holding electron of the hydrogen. So there are two possibilities. Okay. Um, Chlorine is not gaining electron from the hydrogen. Hydrogen is a non-metal. Non-metal cannot donate electron easily. Chlorine is not gaining electron from the hydrogen. If chlorine is gaining electron, so it would be an ionic compound, and we never discuss ionic compound between two non-metals. Ionic compound can be made between metal and non-metal. So in this case, chlorine cannot gain electron during the bonding. Okay, so what is happening during this unfair bonding? Why I'm calling it unfair? Because chlorine is holding the electron of the hydrogen. Okay. Chlorine is more powerful, more electronegative. So this shared pair of electron will be held by the chlorine for the longer period of the time. In other words, this shared pair of electron, it should be shared equally. It should be shared equally in both of the. You can say it should be shared equally in both of the elements. But what will happen here? This electron pair this electron pair will be held by the chlorine, means it will stay for the longer period of the time around the chlorine nucleus. Or you can say it, for example, let's say it is revolving around the chlorine nucleus 100 times, and then it will come back to the hydrogen and it will revolve around the hydrogen nucleus, for example, 10 times. Okay. Now, if I ask you to break it, so there is a possibility. There are two possibilities. For example, we are breaking it. Oh, wait, let me remove it because I have very less space on the screen. Okay, for example, I am breaking it. For example, when I am breaking it, at that time, this shared pair of electron is holded by the chlorine. I mean, at that time, chlorine is holding electron. This is HCl, chlorine is more electronegative. So when I am going to break it, so at that time, there is a possibility that the shared pair of electron is there with the chlorine. So chlorine will be negative and hydrogen will be positive. And for example, at that time, I have broken the compound by thermal decomposition, by electrical decomposition. Okay, so what will happen? I mean, when I broke the compound, the electron pair was there with the chlorine. So I'll get two things, hydrogen and the chlorine. But there is one issue. I'll get hydrogen positive and chlorine negative. Reason? Because the electron was there with the chlorine and I broke the compound at that time. Okay. But there is one more possibility. For example, I'm going to break the compound. Okay. And the shared pair of electron is revolving around the chlorine nucleus and then it is coming back to the hydrogen. So the shared pair of electron is not going like, I mean, not, this is not like that both the electrons are moving toward the chlorine together. No, one electron will move to the chlorine, then other electron from the hydrogen will move to the chlorine. So one electron will come back to the hydrogen, which is the electron of the hydrogen. Then other electron from the chlorine will come to the hydrogen for the sharing purpose. For example, now I am breaking the compound. And for example, when I am breaking the compound, at that time, the electron of the hydrogen is there in the shell of the hydrogen. And all the electrons of the chlorine are there with the chlorine around the chlorine nucleus. And I just broke the compound. So at this time, at this stage, I'll get neutral hydrogen and neutral chlorine. I mean, this is the easiest way that by which I could tell you about it. There are two types of fission. Fission means to break down. There are two types of fission. One is homolytic, one is heterolytic. This is the easiest example you can see. I mean, when we are breaking the compound, we have two possibilities. Either we can break it in ionic form, or we can break it in atomic form. Homolytic fission is that fission. Homolytic, HOMO, homolytic fission is that fission. I mean, homolytic fission is a breaking of covalent compound. The compound should be covalent because we are discussing organic chemistry. I mean, we have to discuss this thing in organic chemistry, and organic chemistry includes all the covalent bondings of the carbon. Homolytic fission is that fission in which covalent bond is broken down in such a way that each atom takes an electron from the bond to form two radicals. And heterolytic fission is that fission in which covalent bond is broken down in such a way that more electronegative atom takes both the electron. This one is heterolytic fission, and this one is homolytic fission. Wait, let me tell you one thing about the radical. What is radical? Radical is not iron or something. Most of the students think that radical is iron. Radical is not iron. Radical is a neutral atom which has one unpaired electron. Any atom which has one unpaired electron and that is neutral and that is highly reactive, that is called radical. I'll give you the example of radical later again. Okay. Homolytic fission is a fission in which covalent compound is broken down to give you two radicals. Two radicals. Why I'm calling it radical? This is hydrogen. Hydrogen has only one electron. This is unpaired electron. And this is chlorine, the neutral chlorine. The neutral chlorine has 7 electrons, 1, 2, 3, 4, 5, 6, and the 7. See, this 7th one is unpaired. What are radicals? Radicals are those elements which are highly reactive and they have one unpaired electron. They have one unpaired electron. And they should be neutral. They should not be ion. Radicals are neutral atom. Number 1, radical are neutral atom. Number 2, they are highly reactive. Number 3, they have one unpaired electron. So if you are breaking the covalent compound in such a way that you are getting two radicals, it means you are doing homolytic fission. If you are breaking a compound and you are getting two ions, I mean the most electronegative one has taken away the shared pair of electron. That is called heterolytic fission. And anyone can be done. For example, if I'm breaking the compound, I never know it would be homolytic fission or heterolytic fission. Sometimes we know, but most of the time we never know. So basically, I mean, what you have to learn here only, I mean, you should know the definition only. Homolytic fission is a breaking of covalent compound in which you get two radicals. Hydrogen is a radical. That is neutral atom that has one unpaired electron. That is highly reactive. Hydrogen is reactive. Chlorine is neutral atom. In this example, the homolytic fission, chlorine is neutral atom. It is highly reactive. It has one unpaired electron. It is a radical. So this is how we declare something a radical. So this is homolytic and heterolytic fission. That's what you should know here. Other than this, let me check if I'm missing something here. Okay. After homolytic and heterolytic fission, we have to discuss nucleophiles and the electrophiles. I have a lot of reactions of nucleophile and electrophile. In every topic of organic chemistry, you can see this thing. So first, you should know what is the basic concept of nucleophile and electrophile. Instead of learning reactions, first you should know the basic reaction. Don't try to learn organic reactions directly. Try to learn their basic structure. Okay, so the nucleophile and the electrophile. Nucleo, N for nucleo, N for negative. This is for the example only. Whatever I'm writing on the screen, this is just to give you the concept. Okay, so that you could learn the concept. Nucleo start from N, so this is negative. So other one will be positive, simple. This is my trick to learn nucleophile and electrophile. Okay. Nucleophile start from N means negative. N for negative, N for nucleophile. If this is negative, so other one will be positive, which is electrophile. Okay. Let's take the example of water. Water has two types of ion, positive and negative. You can write positive one here with the electrophile. You can write negative one here with the nucleophile. Whatever I am writing on the screen, this is just the example to give you the concept so that you could absorb the concept of nucleophile and the electrophile. Don't write this all stuff in your exam. Okay, this is a trick actually. This is a trick to learn this reaction. Okay, so nucleophile and electrophile. Nucleophile start from N, so means N for negative. So other one would be positive. I have just taken the example of water because in water I can see both the things. No? So water can be broken down into positive and negative OH. So positive hydrogen can be written with the positive electrophile and negative OH can be written with the negative nucleophile. Now see, what is electrophile and what is nucleophile? This is H positive. Why this is H positive? I mean, hydrogen has only one shell around it. It has only one electron. Hydrogen has only one shell around it. It has only one electron. Okay. It need only one electron to complete the valence shell because it has only one shell, no? Which is the first shell. If I am taking out this electron from the hydrogen, let's remove the electron from the hydrogen. It had only one electron and I have removed it. It will become hydrogen positive. So what is hydrogen positive? The hydrogen atom which doesn't have any electron. The hydrogen atom which doesn't have any electron. It has only nucleus. It has only proton. That is called hydrogen positive. So this hydrogen positive, I mean, if I want to make this hydrogen stable, so stable, not ion, not atom, I'm using the word stable. If I want to make this hydrogen stable, how can I make it stable? To complete the valence shell of the hydrogen, hydrogen has only one shell, which is the first shell, which can be filled by 2 electrons only. It means hydrogen positive can accept 2 electrons to be stable. It means hydrogen positive is something which can accept the pair of electron. And hydrogen positive is the example of electrophile. So what are electrophiles? Electrophiles are those elements, or electrophiles are those compounds, or electrophiles are those species, you can say. Yes, the word species will work here. So electrophiles are those things which can accept the pair of electron. This is very simple to learn. So if you have to pick up electrophile and the nucleophile, you can write this whole stuff in a rough portion of your paper, and you can pick up the electrophile and the nucleophile easily. Electrophile, H positive. What is the property of H positive? H positive means the empty shelled hydrogen. It can accept 2 electrons, means it can accept the pair of electrons. And I said H positive is the example of electrophile. So electrophile is something which can accept the pair of electron. Or you can say electrophile is that species which has ability to accept electron. जरूरी तो नहीं है वो करे भी accept electron. हो सकता है करे during the reaction, हो सकता है ना करे. It depends ना, organic chemistry के reactions तो वैसे ही हैं. So you can say the electrophile is the species which has ability to accept electron. For example, my ability is to teach bio, but मेरी मर्जी है ना मैं bio पढ़ाऊँ ना पढ़ाऊँ. So same concept इधर. Simple. So electrophile, again, and last time bata rahi hu, electrophile is the species or is something which has ability to accept the pair of electron. Okay. So what is nucleophile? Opposite, which can donate the pair of electron. But we should go with the example. OH is, OH can be written with the nucleophile. Oxygen. Oxygen has 6 valence electron. You can see, if we consider, let me mark with the green one. If we consider these 2 pairs of electron in the oxygen, which I'm circling with the green one, if you consider these pair of electron, these are the lone pair, you can say, or these are the free pairs of electrons which are not participating in the bonding right now, and these electron pairs can be donated during the reaction. These electrons can be donated to make covalent bond or to make coordinate covalent bond. It depends. And OH is the example of nucleophile. So what are nucleophiles? The species which can accept the, the species which can donate or which has the tendency to donate pair of electron. Simple. This is nucleophile and electrophile. But you should know the whole definition. I mean, they are accepting or donating pair of electron. I mean, if something is accepting electron and something is donating electron, so they are doing this whole stuff. They are doing this whole thing to make a covalent bond. So what is the exact definition? The electrophile is that species which can accept the pair of electron to make a covalent bond. The nucleophile is that species which can donate the pair of electron to make the covalent bond. That covalent bond could be any type of covalent bond, the normal covalent bond or the coordinate covalent bond. Now let me tell you one thing. Organic chemistry में example कैसे आनी है? For example, nitrogen. अच्छा, for example, NH3. Everyone knows about NH3. Nitrogen belongs to group 5. It has 5 valence electrons. The 3 electrons are busy with the hydrogen. It has 1 lone pair. Nitrogen, or simple, this whole thing, if you are reacting something with NH3, so NH3 is not acting as electrophile. It cannot accept the pair of electron. जगह ही नहीं है उसके पास. But yes, it has 1 lone pair. It can donate this lone pair to make the covalent bond or to make the coordinate covalent bond with the hydrogen. It will be NH4. So it means NH3 is acting as a nucleophile. It can donate the pair of electron to make the coordinate covalent bond or any covalent bond. This is how you have to study nucleophile and electrophile. For nucleophile, for the nucleophile, what are nucleophiles? I mean, the species which can accept the pair of electron. Sorry, ulta bol rahi hu. The nucleophile, the nucleophile is the species which can donate the pair of electron to make the covalent bond. So NH3 is the best example here, na? Because you can see nitrogen has 1 lone pair, na? And this lone pair can be offered to any element to make the covalent bond, and this lone pair can be donated. So nucleophiles are those species which can donate the pair of electron. And for the electrophile, I just told you electrophile like hydrogen positive, which can accept the pair of electron to make the covalent bond. Example, other than hydrogen, the example was a BF3. BF3, okay, B, boron. BF3, boron trifluoride, fluorine, fluorine, and fluorine. And normally, to stable something, we have to complete their valence shell. तो देखिए फ्लोरीन single bond बना रहे हैं. Fluorine belongs to group 7 halogen ना, so it is making single bond. So इसको तो एक इलेक्ट्रॉन मिल रहा है boron से. Fluorine is stable here, but there is some issue with the boron. It has 3 valence electron, these 3, or 3 electrons from the fluorine are being shared to the boron. 3 plus 3, 6. Boron तो 8 पे जाके stable होगा. It means boron can still accept the pair of electron from any element. So this whole is acting as electrophile here. You can say कि boron जो है वो तो electrophile है ना यहाँ पर, because it can accept the pair of electron. This is all about electrophile and the nucleophile. These are the easiest examples. Always try to practice with the molecules which we have been discussing in organic chemistry. In inorganic chemistry. Inorganic से हमेशा practice शुरू कीजिए. Like this. Then organic के reactions easy हो जाएंगे. Yes, anyone is having any confusion? Yes, Sabu, do you have any confusion?
No, miss.
Okay. Ifa, do you have any confusion?
Yes, miss, I had a question that, for example, what if what can we call something an electrophile if it can accept like 1 electron, not a pair of electrons, like only one?
No. There should be pair of electron.
Okay,
I mean,
okay.
if otherwise, if you say that something can accept 1 electron, so see, a chlorine can be electrophile all the time, means all the halogens are electrophile. Hydrogen is electrophile. Because if you have pure hydrogen, so it has 1 electron. It need only 1 electron, so it can be electrophile. No. Electrophile and nucleophile, you need word pair of electron. Anything which can accept the pair of electron, that is electrophile. Anything which can donate the pair of electron, or anything which has free electron pairs, and it can be donated to make a covalent bond or the coordinate covalent bond. So that is called the nucleophile. तो single की बात नहीं है, electron का pair होना चाहिए. Is it clear?
Yes.
Otherwise, all the halogens will be. I mean, we have to consider all the halogens as electrophile. ऐसा नहीं है. Okay. Let me check. I have to give you worksheet on the weekend so that उसमें ये सारे reactions होंगे. You have to circle the electrophile and the nucleophile. और कौन है भाई हमारी क्लास में? Yes, Hera, do you have any issue or any question? Hera, can you hear me? I don't know why she's not available. Okay, let's continue. So there are few types of reaction in organic chemistry. Wait. Few have been discussed. I mean, you all know about addition reaction. We have discussed about the addition reaction, which can be done with alkene only. Addition reaction means you have to add something without removing anything in a compound. So addition reaction can be done with alkene only. There is no addition reaction with alkane, because whenever you have alkane and you have to do some addition reaction, how can it possible? Wait, for example, this is alkane, ethane. And if I ask you to do addition reaction here, addition reaction means you have to add something without removing anything. For example, if I ask you to add hydrogen into the alkane, there is no bond free. You have to remove something from the compound, then you can add something. So for alkane, there is no addition reaction. But yes, if there is a double bond like this, so this is alkene. Now addition reaction is possible. You can break the double bond. So both the carbon will be having one bond free, and you can attach hydrogen or water or whatever you have. So addition reaction is not for the alkene, but yes, addition reaction is for alkene only. Okay. We have different types of addition reaction, which we have already discussed. Let me remind you, hydrogenation. Oh, yes. Let me tell you one thing. See, addition reaction, we have different type of addition reaction. Addition reaction is for alkene. Mean whenever there will be double bond, we can do addition reaction, and we can break that double bond and we can add something into the compound. We don't have to remove anything. So there are different type of addition reaction. Number one, hydrogenation. Number two, hydrogenation means adding of hydrogen gas. Number two, hydration. Number three, halogenation. In halogenation, we have furthermore classification like chlorination, fluorination, bromination. It depends which type of halogen group you are adding. Okay, these are the addition reactions which are for the alkenes. There is one more thing, which is called elimination reaction. You have to remove something. You have to remove something from the compound. Elimination reaction means you have to remove something from the compound. Dehydrogenation means you are removing hydrogen gas. Dehydration means you are removing water molecule. Dehalogenation means you are removing halogen group. Elimination reaction is just opposite to the addition reaction. Yes, this is totally opposite. See, addition reaction is for the alkenes. You have to add something without removing anything. Elimination reaction is just like a subtraction reaction. You can say elimination reaction is totally opposite to the addition reaction. Elimination reaction is for the alkanes. Means if you have alkane, or not the alkane, I mean if you have any organic compound in which carbon is making single bond with the carbon, you can do elimination reaction. You can remove water or the halogen. Wait, I mean addition reaction. What is the addition reaction? You have to add something into the alkene, means the double bond thing, and there will be single bond at the product side. But in elimination, you have to remove something from the single bond thing, and you will get something something double bond. Let me give you the example. Elimination is totally opposite. You don't for the addition reaction you have to use some double bond compound like alkene. Let's discuss the elimination reaction in alcohol. Let's remove water. Let's do dehydration. See, this is alkene. I am removing water means I am removing this and this. So the water will be removed. And what I'll get? C, say hydrogen, 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 hydrogen. Carbon always make 4 bonds. Here it is making 3 bonds. So the other bond can be here, the double bond between the carbon. This is the elimination reaction. I have removed water, but I didn't add anything into the compound. I have removed water. This is elimination reaction. I mean, this is alkane. So elimination reaction of alkane can give you alkene. But if we go back, like if we go in a reverse direction, so see, this is alkene, and hydration of alkene can give you alkane. So if you're coming top to bottom, like on top we have alkene. So if you're removing water, that is called dehydration, elimination reaction. It is giving you alkene in the water. And if you are adding water back into the alkene, means you are doing addition reaction, means you are doing hydration. It will give back alkane to you. This is so simple. So this is the elimination reaction, and addition reaction. Both are just opposite to each other. Okay, let me check if I'm in elimination reaction, you just have to remove anything from the compound. You don't have to add anything. And elimination is for the single bond thing. It will give you alkene at the product side. Addition is for the double bond thing. I mean, you have to use alkene at the reactant side, you will get alkane at the product side. Or you will get some single bond thing at the product side. This is how you can learn this. The substitution reaction is very easy. Substitution reaction is another name of um, substitution reaction is another name of like displacement or the replacement reaction. For that, you should know the reactivity. We have already discussed substitution reaction in yesterday class, but let me give you one example again. For example, we have propane, and here we have bromine, and all the bonds are filled with hydrogen. For example, if I'm reacting it with NaCl, this is something like alkane, because all the carbons are joined with each other with a single bond. Okay, if I try to react it with NaCl, so basically bromine has to be replaced by the chlorine. So first you have to check if the chlorine is more reactive than the bromine, then you can substitute it here. Otherwise, there will not be any substitution reaction. So yes, as we move down in a halogen group, the reactivity decreases. Bromine comes after the chlorine, so bromine is less reactive. So the chlorine can replace the bromine. So it will be like this, Cl, and you will get NaBr. Okay, so this is substitution reactions. Substitution reactions are easy, but you should know the reactivity series. And here you should know the reactivity series of halogens only, and everyone knows as you are moving down. So in a halogen group, in group 7 or 17, so the reactivity decreases. Fluorine, chlorine are more reactive. We will not use fluorine here in organic chemistry, but you should know what is the reactivity difference between chlorine, bromine, and the iodine. Okay, the other reaction, we don't have to discuss that reaction because we have already discussed this reaction, which is condensation reaction. We discussed it yesterday. What was condensation reaction? For example, you have one monomer and you have one more monomer. You can remove water molecule and you can join those monomer together, you will get a polymer. So what is condensation reaction? In which you join two molecules by removing water. Condensation reaction will give you a polymer. We did it in the example of Easter. Yes, we did the example of Easter yesterday. Okay, so what is condensation reaction? You have two monomers, you have two things, you are joining those two chemicals, two compounds, or two monomers together, but you have to make some bonds free now, so you are removing water. You don't have to remove water all the time. You can remove HCl sometimes. It depends which type of polymers we are making. Well, that is another discussion. What is condensation reaction? Condensation reaction means you are joining two monomers together by removing water molecule. You will get one polymer. Then what is hydrolysis? This is also a topic of biohydrolysis. I mean, enzymes sometimes hydrolysis करके compounds को break करते हैं. For example, this is a polymer. Hydrolysis is just opposite to the condensation. Means you have a polymer, add water back into the polymer, so it will break into two monomers. So condensation means joining of two monomers together by removing water. Hydrolysis, broken down of the, or you can say breaking of the polymer by adding water, or breaking of any compound by adding water is called hydrolysis. Example मैं आपको देती हूँ इसकी क्योंकि example जरूरी है इधर. For example, ये बायो में भी हेल्प करेगा आपको. अब फैट की ले लेते हैं ना. फैट के लिए we have glycerol and 3 fatty acids. So glycerol and 3 fatty acids, they are monomers. You have to remove 3 water molecules and you will get a polymer which is a fat. ठीक है. लेकिन आपकी बॉडी तो फैट एब्जॉर्ब नहीं करती according to your bio, according to A levels bio. आपकी बॉडी तो एक्सेप्ट नहीं करती है फैट्स को. So what will happen? There will be some enzymes. They will do something like hydrolysis of a fat, means they will add water into the polymer, which is a fat, and the fat will be broken down into its monomer, which is glycerol and the 3